We are going to be looking at 6D from the Unit 3 and 4 Cambridge textbook on focusing on graphing a sine and cosine function. So let's look at the basic sine function. So the first thing I want us to think about is the unit circle, because that is in essence what our sine function is at the moment. So you can see if we go around, we're starting at 0, which is what our sine does. And if we think about at the start when we've got sine of 0, it just will give us 0 because that is our y value. Likewise, when we get to pi 2, sine of pi 2 is going to be 1 because that's our y value for unit circle, and that's what it does here. Then it goes back down for pi, and sine pi will give us 0 because our y value is 0. Then sine 3 pi over 2 will give us the y value of -1, and then at 2 pi it goes back to 0. So this is what we need to use our understanding of this unit circle. So there's one of the things we need to think about is the period of a sine graph is 2 pi, because it's going the full loop around our circle. Now, because it's a unit circle, our amplitude is how high or how low it is. And at the moment, we have our amplitude just at 1 for a unit circle. So it goes from -1 through to 1. But remember, the amplitude is always going to be a positive. If we look at cosine, again, same thing I want us to think about. Cosine 0 is 1, which is the reason why at 0 we're starting at 1. Then when we get to pi over 2, cosine pi over 2 is 0 because our x value is 0, which is why we've got an intercept here. Then we go down to pi, and pi is -1, which is why at when it's pi, it is -1. And then we go to 3 pi over 2, and cosine, referring to our x, would be 0 there, which is what we've got right here. And then finally, when it gets to 2 pi, cosine 2 pi is +1, and that's what we've got going up to the 1. So again, the unit circle clearly maps our shape of our cosine function. Now, because we're going around a unit circle, we can clearly see our period is 2 pi and our amplitude is 1 at the moment. Now let's look at dilation. So dilation is, we refer to stretching away from an axis. So for example, if we have 2 sine x, it's a dilation factor of 2 from the x-axis because it's pushing away from the x-axis. So this point here, when it would have been 1, it's been times by 2 to get to 2. So that is a dilation factor of 2. That means whatever our y value is, we are just timesing it by 2. The same thing applies with cosine. With cosine, that dilation factor of 2 is stretching away from the x-axis, which means instead of having -1, we have -2. We've times it by 2. Another thing I want us to think about is this 2 at the front. Yes, it's stretching away from the axis, but we call that our dilation. So as we call that our amplitude. So our amplitude here is 2 because the middle line at the moment is 0, and it's 2 away from that middle point. We can write it as dilation factor of 2 from the x-axis, and I can write it as a mapping coordinate as well. Next, we're going to be looking at the transformation again and dilation, but this time we're looking at y equals sine and x. So we know when it's affecting the x, all that means is it's going to be pushing away from the y-axis. And that's what we can see here. It's either compressing or pushing away. So At the moment, that n value is a dilation factor of m from the y-axis. So let's look at this. Our sine x, we naturally have a period of 2 pi. Now we've got y equals sine 2x. So this 2 means it's a dilation of half. So it's going to half my uh, it's going to half my the period. So which means it's grabbed it and pushed it in half. So we can see this was originally 2 pi the period. It's halved to 2 pi. So our period is now pi. Our mapping coordinates is whatever our x was, we are just dividing it by n. Let's look at this next one. We've got our cosine, y equals cosine nx. Same thing applies with this. So our basic graph of cosine is 2 pi, but this time when I've got 0.5 in front, what this is doing, it's like me saying x over 2, which means it is going to be stretching my graph out away from the y-axis, is what we can see, which means it's doubled my period to 4 pi. So this is a dilation factor of 2 from the y-axis. So remember, we would always write it with x over n. Our n value here is 0.5. So because it's 0.5, it's the same thing as me saying I am timesing it by x by 2 and having 2xy. So this links into us knowing our period and knowing our amplitude. So our amplitude, that will always be the number in front of the sine and cosine. Our period for sine and cosine always will be 2 pi, and we divide it by that n value. So for instance, with this function, I've got y equals 4 sine 3t. My amplitude is 4, and my period will be 2 pi over n, and it's 2 pi over 3. Negative 2, just remember that negative is just a reflection in the x-axis. So that is not part of our amplitude. So for negative 2 cosine 2t, my amplitude is literally 2. My period is 2 pi over my n value, and that's 2 pi over n, which is 2 pi over 2, which I could say is pi. Y equals 3 over 2 cosine 5t. My amplitude is 3 over 2, and I can write it as 2 pi over n or 2 pi over 5. Let's describe the transformation that is occurring in both of these. Then look when we identify the amplitude and period. So the first thing we need to think about is delta t. Dilation. What dilation do I have? I've got a dilation factor of 2 from the x-axis, so this is stretching away from the x-axis. Then this 4 is a dilation factor of 1/4 from the y-axis, which means it's compressing. From that, now I look at amplitude, and I've got amplitude of 2, and my period will be 2 pi over 4, which is pi over 2. Then I look at the next part. F of x is equal to negative 3 sine negative half t. So we start off with our dilation, delta t. So our dilation, we've got a factor of 3 at the very front from the x-axis. Then we've got a dilation factor of 2, because this is half here, from the y-axis. Then we need to look at our reflection. So this negative out the front is a reflection in the x-axis because the y value is changing. Likewise with this negative with negative a half, it's a reflection in the y-axis. My amplitude is 3, that's not changing. And with my n being a half, then my period will be 2 pi over 0.5, which is the same as 4 pi. So let's have a look at sketching. So if I'm sketching 3 sine 1/3 t, step 1 is to identify the amplitude and period. Well, straight away the amplitude is 3 out the front. So that means at the moment, without any vertical shift, it will go from 3 to -3. Then I've got my period, the n affects it, which is 1/3. So that means I'm going 2 pi over n, which is 2 pi over 1/3, which is 6 pi. Do I have any reflection? No. And so now I know this, I am then able to graph. So I find my points. Now, because I know the period is 6 pi and a sine will always start at the origin, that means I can just go, well, what's the halfway point? Which will be 3 pi. What's the halfway point of 3 pi? 3 pi over 2. And what's the halfway point here? Which is just 3 pi plus 1.5, which is 4.5 pi. So be mindful, it's same thing every single time. Likewise, with y equals -4 cosine half t, when we find out our amplitude, it's just the 4 in front, it's not the negative. Likewise, with my period, it's 2 pi over n. In this case, my n is a half, so it'll be 2 pi over a half, which turns into 4 pi. Then I need to identify if there's any reflection, which I do. I have a reflection in the x-axis, and then I can graph it. So when I graph, the first thing I need to think about, cosine normally starts at 1, or in this case 4. The reflection means it will start at -4 and it will end at -4. Because of this is 4 pi, the middle point I'm going to find will be 2 pi.